Prepare to embark on a mind-bending odyssey into the hidden realms of the universe as we unravel the enigma of mysterious cosmic rays. Get ready to dive into the mind-boggling mysteries of cosmic rays, where the frontiers of science blur with the realms of the unknown, leaving us with more questions than answers. Get ready to be astounded, for the cosmic enigma awaits. In 1912, Austrian physicist Victor Hess was using balloons to measure radiation levels in the Earth's atmosphere. His innovative and meticulous work required him to travel with the balloon up to altitudes of 5.3 kilometers, monitoring the measuring equipment and checking data. The danger of traveling to such heights paid off for Hess. Unexpectedly, he found higher levels of radiation as the balloon rose and concluded that radiation was penetrating the atmosphere from outer space. The mysterious radiation was eventually called cosmic rays. 100 years later. 100 years later, the nature of cosmic rays is well known. They are charged subatomic particles raining down from outer space. However, their origin is still a mystery. Two theories predominate: that cosmic rays come from massive black holes at the centers of active galaxies, or the massive fireball thought to be produced during gamma-ray bursts, GRBs. Using data from the IceCube Neutrino Observatory, astrophysicists Nathan Whitehorn and Pete Redl searched for neutrinos coming from the direction of known GRBs. And they found nothing. Their result, appearing today in the journal Nature, challenges one of the two leading theories for the origin of the highest energy cosmic rays. If gamma-ray bursts are indeed the sources of cosmic rays, they must emit neutrinos. The model maintains that neutrinos are produced in the interactions of protons and photons coexisting in the GRB fireball. Out of the sky and into the ice. Where Hess took his research to the skies, the IceCube collaboration headed in a different direction, deep into the ice. The IceCube Neutrino Observatory is a high-energy neutrino telescope built into the ice under the geographical South Pole. When a neutrino collides with a nucleus in the rock or ice inside or near the observatory, IceCube detects the faint blue light emitted by a secondary particle called a muon. Neutrinos are ghostly. They can easily travel through people, walls, or the entire planet Earth, rarely interacting with regular matter. IceCube is built on an enormous scale to compensate for the antisocial nature of neutrinos and catch their rare collisions. This ghostly nature allows neutrinos to travel enormous distances from gamma-ray bursts to the detector on the Earth. 1 cubic kilometer of clear glacial ice, enough to fit the Great Pyramid of Giza 400 times, is instrumented with 5,160 optical sensors. IceCube was constructed using a hot water drill. 86 holes were drilled to 2.5 kilometers deep, and a string of sensors was deployed in each hole to complete the array. IceCube construction was finished in January 2011 by a collaboration of 250 physicists and engineers from the USA, Germany, Sweden, Belgium, Switzerland, Japan, New Zealand, Australia, and Barbados. The GRB neutrino search. GRBs are extremely powerful explosions, first observed by satellites using X-rays or gamma rays. GRBs are relatively frequent occurrences, seen about once per day around the visible universe. Typical GRBs last a few seconds, and during this brief time, they can outshine the rest of the universe combined. Despite this, little is known about them. Whitehorn and Redl studied 300 GRBs reported by satellites on the GRB Coordinates Network between May 2008 and April 2010, looking for any neutrinos originating from the observed gamma-ray burst position and time. At the time, IceCube was under construction. In the year from May 2008 to April 2009, it had 40 strings, and in the second year of the study, IceCube operated 59 strings. 2 independent data analysis methods were used, and both resulted in no evidence for neutrinos being produced by GRBs. Bringing cosmic rays down to Earth. It was August 1912 when Austrian-American physicist Victor Hess began a series of flights to the upper atmosphere in a hydrogen-filled balloon equipped with an electroscope, his aim to take measurements of ionizing radiation. At the time, it was widely believed that radiation from the Earth itself was responsible for this phenomenon of knocking electrons off atoms. Should this be the case, however, ionization should be strongest near the planet's surface. Hess discovered something startling. At a nosebleed-inducing altitude of 3.3 miles, 5.3 kilometers, ionization rates of the air were 3 times that measured at sea level. He concluded that the source of this ionization was not coming from below our feet, but instead from above. Further measurements made during a solar eclipse also showed the sun wasn't the source of this ionization radiation. During 7 balloon trips, Hess discovered cosmic rays, confirmed and named by Robert Millikan in 1925, coming from beyond our solar system. But while the detection of cosmic rays has been associated with balloon flights ever since, the upper atmosphere isn't the most convenient laboratory to investigate the high-energy particle collisions they produce. Future directions. The lack of observation of neutrinos in coincidence with GRBs implies, at face value, that the theoretical models need to be revisited. Calculations embracing the concept that cosmic ray protons are the decayed products of neutrons that escaped the magnetic confinement of the GRB fireball are supported by the research community and have been convincingly excluded by the present data, says Francis Halzen, IceCube principal investigator and a professor of physics at the University of Wisconsin-Madison. IceCube will continue to collect more data with a final, better calibrated, and better understood detector in the coming years. Since April 2011, IceCube has collected neutrino data using the full detector array. With the larger detector, researchers can see more neutrinos, providing a higher resolution picture of the neutrino sky. As we reach the thrilling conclusion of mysterious cosmic rays, we find ourselves on the precipice of understanding the hidden secrets of the universe. Cosmic rays, those enigmatic particles hurtling through space with unfathomable energies, beckon us to delve deeper into the realms of physics and astrophysics. They challenge our current knowledge and push the boundaries of what we thought possible. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.